Assalamualaikum, hi guys. I would like to continue with our lesson chapter number 2. This is about factor interactions. Okay, if you look at that, this is about a species of organisms called urehaline or eurythermal. Uri is referring to wide tolerance. Meanwhile, for narrow tolerance, a steno referring to organisms called stenohaline or stenothermal. Organisms with a wide range to tolerance, widely distributed and affected by age, season, physiological or behavioral states. For example, here, as you can see from here, this is a picture showing you salmon, okay? A fish called salmon. Salmon normally will, salmon eggs and larvae, they happen in fresh water. This is called stenohaline. While adults, they are breed or live in marine. This is called urehaline. So next one is actually about adaptation to limiting factors. In one environment, a given factor may be limiting but not so for another. For example, oxygen. Okay, if you look at an example here, oxygen, okay, is limiting in a deep lakes, seas and higher altitude but not on land. So this is adaptation of two limiting factors. Next one is ecotype. Ecotype is actually due to evolutionary relationship to more closely related species with more similar intolerant to given factors. As a definition, ecotype is actually a subspecies or race that is especially adapted to a particular set of environmental conditions. Ecotype also is a populations adapted to local conditions. For example, Tuxu Z dolphin, okay, from your left hand side up there, there are two ecotypes. Okay, number one, the riverine ecotype found in some South American rivers. Meanwhile, for the second one, the pelagic ecotype found in the South Atlantic Oceans. Example number 2 from your right hand side on top of this slide. Okay, temperature tolerance of the jellyfish from two populations, northern and southern. This is also the same thing happen in the plant. As you can see from here, different level of high of in geography, I mean the region, there are different type of species will be growing. I mean the physical appearance. Okay, as you can see from here, so this is the plant that grow in different type of level of low, middle and fan gardens. Okay, at low level, moderate level and high level. Okay, as you can see from here, as usual, a plant they needs sunlight, okay, to absorb sunlight for their own to perform their photosynthesis. Okay, as the plant receive very little amount of the light intensity, of course they become dwarf. Okay, especially at the high level, okay, the right hand side one, the plant becomes small or dwarf, very small one, because of the receiving of light intensity. Okay, and accordingly with another levels. Adaptation only produce better individual and not the best. Okay, so there are 4 constraints to adaptation, which are number 1, genetic force, number 2, environments, adaptation in compromise, number 3, and the last one is historical constraint. Again, the constraint of 4 constraints of to adaptation. Number 1, genetic force such as a mutation and gene flow prevent adaptation. Most mutation are detrimental rather than adaptive. Meanwhile, for environments are continuously changing. Number 3, adaptation is a compromise, gain in one and lose at another. There is only a limited amount of energy and time. For example, a loon, a type of bird, have wings They are adapted for diving but not so efficient for flying. Number 4, historical constraint. All organisms have a history and change in a small increments. So this is about co-evolutions of arm race. Okay, what happened here? Mutually evolutionary influence between two species. The evolution of two species totally dependent on each other. Each one of the species involved puts selective pressure on the other, so they evolve together. For example, here is herbivore and food plants. Okay, as you can see from here, a predator relationship between predator and prey, host and parasite. So this is example number 1 about co-ovulation, arm race, host, parasite. Okay, the number you can see, as you can see from your right hand side, there is an egg, the white color, four eggs, white eggs, and just one different color one, the brown, got a spot, brown spot. Okay, brown-headed cowbirds in North America, they crave a living by following herds of bison or cattle and feeding off the insect that the beasts attract. Their nomadic lifestyle, this make bringing up young problematic. So they get over this obstacle by becoming brood parasite. In other words, they recruit different bird species to unwittingly raise their young. Very simple, they lay their eggs in the nest of an unsuspecting songbird like the east, poor, and leaf. So what happened later on? Parasite birds lay their eggs that closely mimic those of the host and young with characteristics that encourage the host to feed them, same color, size, pattern, and host. The host then provide parental care to the unrelated young that hatch from the parasitic egg, often to the detriment of their own young. So both parasite for cowbird chick and host species songbird chick are continually evolving counter strategies for survival. So again, cowbirds who share their nest with another host chicks actually succeed. They grow much faster and cowbird chicks reared alone. This is because the host parents work disproportionately hard to feed a full nest, and because the cowbird chick is rather become more robust, it gets more than its share of the food. Cowbird gains disproportionately from the higher provisioning because it could overpower the host young and take more than its fair share of food. Example number 2 is actually about yucca moth as a pollinator, and yucca plants provide home and food. Okay, yucca flower are a certain shape, so only that tiny moth can pollinate them. The moth lay their eggs in the yucca flowers, and the larvae or caterpillar live in the developing ovary and eat yucca seeds. Example number 3, acacia ants as a protector, and as acacia trees provide home or food. Acacia are small, central American trees in the Leguminaceae. They have a large hollow thorns. The acacia ants live in the thorns. On the tips of its leaflets, the plants make a substance used by the ants as food. The ant defends the tree from herbivores by attacking or stinging any animals that even accidentally brushes up against the plants. Last one, this is a mutualistic relationship within plant and pollinator. Many plants depend on animal to spread their pollen. This is mutualistic relationship where the plant and the pollinator benefits each other. The plants expend less energy on pollen production and instead produce showy flowers, nectar, and others. Some plants or flowers are more general while others are more specific. I think that's all for today. Thank you.